In this video, we're going to review some basic algebra ideas. If you're comfortable with algebra and confident that you know how to do all of these things that I'm listing here, then go ahead and click on this button and it'll take you right to the quiz for this video. If not, hang tight, we'll work through some of these processes. Let's start off with manipulating equations. So lots and lots of times in basic science classes, you're going to be presented information in the form of an equation, and you'll be responsible for rearranging that equation and manipulating it in a way to get useful information from it. So I'm showing two examples here. The first one is an equation that includes y and x. So y equals 3x plus 2. And our task is to solve for x. So to do this, what we want to do is isolate x. So we need to get x by itself. We can start off by subtracting both sides by 2. So we end up with y minus 2 equals 3x. And then we divide both sides by 3. In this case, the 3 cancels out. There should be a 3 there. And we end up with y minus 2 divided by 3 equals x. So we've solved for x. So if you're given a value of y, you can plug it directly into this equation so you can solve for x and figure out what value x would be. Let's try another example. In this case, we have 7y plus 2 equals 16, and we want to solve for y. So we want to figure out the numerical value for y. So we want to get y by itself. We'll start by taking both sides minus 2. So I have 7y equals 14, and now both sides divided by 7 to get y equals 14 divided by 7, which is 2. So y equals 2. Let's try another problem. So we'll explore distributing values through parentheses. Distribution in parentheses. Okay, so in this first problem, we have x equals 3 times y minus 4. So what we want to do is simplify this. Okay, we can do this by taking this 3 and distributing it into the parentheses. So this 3 gets multiplied by y and by negative 4. So what we're left with is x equals 3y minus 4 times 3, or x equals 3y minus 12. So whenever you have a value outside of a parenthesis, you can distribute it into that parenthesis. Just make sure you take this value, this 3, times everything that's added or subtracted. So let's see another example. In this case, let's say we have x equals 4 times 3y plus 4z plus 7. Okay? So we're going to approach this problem in the same way. We take this value of 4 and distribute it into each piece of our parenthesis. Okay, so every time you see a plus sign or minus sign, this 4 gets distributed into the piece around that. So in this case, we end up with x equals 4 times 3 times y, so 12y, plus 4 times 4, which is 16, times z, plus 4 times 7, which is 28. The opposite of distribution into parentheses is factoring out of parentheses. Okay, so if we see a problem here where we have x equals 27y plus 9b plus 18, so what we see here is that 27, 9, and 18 are all related by a factor of 9. 9 times 3 is 27. 9 times 1 is 9, and 9 times 2 is 18. So recognizing that these three values are all related by the factor of 9 allows us to factor 9 out of this equation. So in this case here we have x equals our factor, which is 9, times 3y plus b plus 2. So if I were to redistribute this, if I were to take 9 and distribute it into my parentheses, like we did above, we would see that x equals 27y plus 9b plus 18, which you'll recognize is what we had up here. So these two expressions, this expression and this expression, are equivalent. It's just in one case the factor of 9 is factored out, and in the other situation is distributed in. Let's go ahead and see one last type of algebraic manipulation that is really useful to be comfortable with in this class, and that's solving multivariable problems. Okay, so you will see situations where you have two unknown values, so two variables. So for example, if we know that x times y equals 80, we don't have a way of figuring out exactly what x is or exactly what y is from the information that we're given here. But if we're told that in addition to x times y equals 80, that also x divided by y equals 0.8, now we have two equations that include both of our variables. And because of this, we're actually able to figure out the value of each of these variables. So the way that we want to approach this is choose one of our equations and solve for a variable. So I'm going to choose this second equation, and I'm going to solve for x. So if we take both sides times y, we end up with x equals 0.8 times y. And this is useful because we know that under all conditions, x equals 0.8 times y. So we can take this value and plug it in for x in our other equation. So I have 0.8 times y, which is x, times y equals 80. So we distribute y into our parentheses, so we end up with 0.8 times y squared equals 80. And now I'm in a position where I can solve for the one variable that I have here, which is y. So I'll divide both sides by 0.8. I have y squared equals 100. I can take the square root of both sides. And remember, in a previous video, we saw how you can put a square root into your calculator. So we end up with y equals 10. Now that we know that y equals 10, we can plug this into our second equation because x equals 0.8 times our value of y, which is 10. So x equals 0.8 times 10, which is 8. So whenever you have two unknown values, two variables, you need to have two equations that describe each of those variables to be able to solve for either of them. So these are some common algebraic and mathematical problems that you'll need to be comfortable with as you move through the material in this class. So the quiz is going to assess your ability to solve some of these simple problems, and then as the class progresses, you'll see more and more of these and get more practice using them.